Hey everybody, we are live on YouTube right now. We got some Red Bull, so we are ready to go. How's everyone doing? Good to see everyone in the chat. We're gonna do a little project help today. Everyone doing good? Good to see you, Olivia. I saw Andrew, Anna, Jackie, Jessica, everybody in the chat. Good to see you. I got coconut Red Bull. Best way to do this. Let's hop over to our screen right here. So let's do this. Okay, so I'm over here now just working on the project stuff, and let's see. Now, I'm going to make this a little larger here. Let's do this. There we go, look at that. I'm not going to do your exact questions. What we're gonna talk about today is mainly you're like, oh no, everyone just clicked away, the viewership just drops right now. You're going to ask about certain questions like, one, we should know how to take a random sample by now. If you notice, I'm not working with your data. I'm working with data very, very similar to the data you're working with. So one, don't use this data. Good to see everyone here. So good to see everyone in the chat. Don't use this data right here. This is data from previous projects. So what we want to do is we want to go into here, and we want to go to tables, and we want to go to subset. This is one of the first things we do. And you're taking the sample size of 254 or something like that, and we're just gonna hit enter twice, and we have a random subset here now. So one, you wanna always make sure when you're working on your project that you always have your random sample that you're using right here. So this is key information right here that you have a random sample that you are using. It should be 200 plus the last two of your UTID. That can be major points off on the project. And so the first thing we do on the project is we take a random sample. That is it, not the 0 zeros. It'll be anywhere between 200 to 299. Everyone's random sample will be anywhere from 200 to 299. So look at the last two digits and it will be everything. We are live, are we good? Everyone can hear and see me, right? I think everyone can. I think the link I sent out was correct and we don't have any weird echoes. We're good, okay, we're good. And I think we're on ultra low latency. I'm fading away, hopefully I'm not fading away too much. I might work on that, I don't know. The black shirt is showing up a little bit, transparency, but we've got good stuff right there. It's as long as we know it's you, use the same numbers you've been using throughout multiple projects. Good to see everyone here, just so good to see everyone in the chat and talking. So Bridget, Jackie, Andrew, Keaton, everyone, so good to see you. So does everyone understand, I will be in office hours tomorrow, and then today I had meetings, so I decided this would probably be best right here. So does everyone understand what ID numbers to use, which ID numbers to use? You can use the 0001 as long as we know it's you. It would only come into question if we're like, wait a minute, this isn't you, you didn't do your project. Use the same numbers you've been using throughout your projects. What question does anyone have on anything on the project? Maybe it's about the proportion stuff, or maybe it's about the quantitative stuff. It'll be for the next one, Bridget. Can you help with the add-ins? Yeah, the Excel add-ins, let's do that. So we got to bring up Excel right now. So what we need to do is we need to go here to File, and on this one it's going to be Save As, and you have to go here to Excel. Now I'm doing this on a, let's go here to random sample, or we'll have to type eventually. So this is how you save it on a PC. So that is saving it. Hey, good to see you here, Julio. We're excited for later on. So good to see you. Everyone's like, who's the special guest? I haven't said who it is yet, but we got special, so yeah, good to see you, Julio. So with this right here, project help and then special guest for 505 later today. This is when we're doing the summary statistics right here in the Excel add-in. So let's look at this, and there are videos on how to get the Excel add-in. So let's show this right here. The question was, how do you get the Excel add-in? You can't be using Excel online. You can't be using Excel online. You have to be using a version that is installed on your computer, and I'm gonna do it on the PC here. And so this is fun because I don't always do this. There we go. This is how to do it on a PC. Let me show you again. On a PC, you have to go to File, you have to go to Options. Under File, you have to go to Options. Then under Options, you need to go to Add-ins. And then under Add-ins, you need to click down here to Excel Add-ins and click Go. And then you have Analysis Tool Pack. We have now done it. And unfortunately, I don't have a Mac at my disposal right now to show you how to do it on a Mac. Be nice to know so we could ask some questions. Uh, Julio, do you think we should announce who the special guest is? I haven't said who it is. Maybe I should send it out. The students, they want to know who it is. If Julio wants to announce it, then Julio thinks, and it is Julio Bourbon. Hopefully I'm pronouncing it correctly. Julio is our special guest for later today. I'll send that in the next announcement. But it's so cool. Played professional baseball for 6 or 7 years. I think about 6 or 7 years, is that correct? And currently working with professional baseball teams. So one part of MLB and still part of MLB, which is awesome. We're gonna talk about analytics. 12 years, I just 7 years, 12 years, I downplayed that. I pulled up your stats and it was long and I was like, that's a lot of years. And for me, 7's a long time, but 12 years, whoa, 12 years, that is awesome. That is amazing. And so I'm sorry, 7 years, I thought, I just went and I scrolled and that's like, that's a lot of seasons in the major leagues. But yeah, so it's so good to have you and we got a lot of excitement about it. I'm hoping, so if you're in my class, make sure to come into the next lecture and we'll be doing an interview just talking about analytics with baseball, and it'll be really exciting and you'll get to see Julio on the big screen. Jason's working on a screen right there. So good to have you. And I love hearing about how the utilization of baseball with statistics is being done, and we just want to hear your experience with it. And so I'm super excited. I know it's going to be really cool. So, and Jason's working on some graphics for us right now. He's over there. So, does everyone understand at this point in the chat how to get your data into Excel, and then also how to get the Excel add-in? Does everyone understand how to get your data into Excel and how to get the Excel add-in? How are we doing on that? There are some videos I have on YouTube for that, but you should have now under the Data tab, you should have a new button here called Data Analysis. We're doing great, it sounds like. So there's now a Data Analysis tab up there, that tab all the way up there. I wish I could just zoom in. And there is a video for the Mac. If you're looking at the project instructions, there should be the video showing how to do it. Okay, do this. You ready, Anna? Click on, you have to click under Tools. I'm doing it from memory right now. You have to click under Tools and then Add-ins. And there's like two things. You can click all the way at the top or you can click on the menu. And I can't remember which one it is. But you click under Tools, Add-ins, and then you should have the Data Analysis add-in. Tools, Add-ins, and then the Data Analysis add-in. It should be there, or check the video. Sorry, I only have PC at my disposal right now. But it is available online via video. So now that we have the Data Analysis tool pack on here, let's go ahead and click it. And we're going to go over here to Descriptive Statistics. With Descriptive Statistics clicked, we're going to pick a quantitative variable. You got it, great job. Yes, perfect. I didn't remember it. I remembered it from memory. Let's go here to the high school GPA. If you notice, I'm just clicking the top column of it, and then I'm going to click Labels in first row because the label is in the first row. Then I'm going to go to Summary Statistics Confidence Interval, and then I'm going to click OK. It's already set up to be in a new worksheet, and there you go. Now here's what I like to do. So remember, this is being recorded. I like to make it look all nice and pretty. So we go right there, we put it in a new tab. We come up here and we double click. There we go. When you double click, it auto spaces. I put it over here so I can kind of work with it and make it look really nice. And so we're just going to put it right here, center on the screen so we can see it really well. And now I'm going to work with it. I want to make this look really good. I'm going to take away this space right here. And we're going to talk about this data in a second. I'm going to highlight everything. We're going to go to the main part of the screen. We're going to put a nice bright border around it. Then we're going to put a border around here. And we could leave it at that, but let's center this. This is all the stuff you can do if you want. And then let's go inside of here, and let's do borders inside of here. And then let's go borders on it like that. Let's go and color this in, make it yellow, bright yellow. Let's color this in and make it light blue. Everyone's going to have the same colors now. It's all right. You can pick whatever colors you want. And now we got what looks like a spreadsheet. Now, of course, what you want to use is you want to use the snipping tool or Command-Shift-4 on a Mac and go ahead and take your snip and go right there. Nice good edge on that. And there we go. So we now have our graphic. We have our output. We'll put it here. So this is your confidence interval. Now this is not the one that you're doing, but it's almost identical. And Natasha, you are right next to me, right here. It's so weird, I'm in one of those like, I don't know where I'm pointing at stuff. That is the margin of error. So when you look at this interval right here, it's 37.4, I go off the screen when I do that. That's the mean, so the mean is the center. And oh, can I draw on? I can't, my pen is back though. The pen is back, I can't draw on this. I can draw on Excel, that's amazing. So, it is y bar plus or minus, and you could simply say the margin of error. This is y bar, and down here a little bit further, that just made my day. That was the best thing ever. So, and this is the, it doesn't take much to please me. This down here is the margin of error. So I hope that helps you better understand. I'm gonna move to the side a little bit here. Oh no, I know, I'm fading away. It's, someone went back in time and stopped my mother and father from meeting, and it's Back to the Future all over again. And we'll fix the alpha level between classes here. But does everyone understand what you're getting right here, that this value is the mean, which is the center of the interval, and this value right here is the margin of error. It was Biff Tannen, oh my gosh, Biff. Biff's just a bad guy. This is a bad dude. So right here we have the mean plus or minus the margin of error. And does everyone understand what's going on exactly right here? Now this isn't the full way we usually write out the confidence interval. It's usually y bar plus or minus a t statistic with n minus 1 degrees of freedom, and then s over square root of n. You can also write it out the same way as y bar plus or minus, you can put a star on the t. Star means you get to pick it. T with degrees of freedom, which is n minus 1, and the next thing is the standard error of y bar. All of those are pretty synonymous ways of writing it, because y bar plus or minus the margin of error, well, the plus or minus is the margin of error. The margin of error is t star with n minus 1 degrees of freedom, s over square root of n. S over square root of n is the standard error. That's just an abbreviation, just to highlight. This s over square root of n is the abbreviation of it, and the margin of error is everything right here. The degrees of freedom are n minus 1, so when you see me do a subscript right there. How do you calculate the alpha level? Great question, which we're also going to talk about today in class. Let's hop over, or let's scroll down just a little bit right here, since we've got like a free area to draw in. Great question, Natasha. So let's see if you have, let's do two examples right here. If you were to make a 95% confidence interval, or a 90% confidence interval. So here's a 95% confidence interval and a 90% confidence interval. So you got it. It's normally 0.05, but let's say why is it 0.05? If you were to shade in 95% in the center between those, what would be shaded on the outside? With 95% in the middle, what would be shaded on the outside? And you might be saying it right now, and this is basically the answer to the question, but we're also kind of teaching it. A 95% confidence interval is the same as using an alpha level of 0.05. But here's the big thing. A confidence interval is the same mechanically as a what-tailed test. Now look at it. A confidence interval is on the far side of the screen right now, over there. And right here you see a two-tailed test. Well, I just gave it away. A confidence interval and a two-tailed test are the same mechanically when you look at like an inside-outside way of doing it. So when you have 90% on the inside, which we need to draw these a little bit closer now. So when you have 90% on the inside, a 90% confidence interval, anything outside of it can be rejected at an alpha level of 0.10. So, and listen to carefully what I say, if I can speak properly. With a confidence interval of 90%, any value outside that interval can be rejected on a two-tailed test with an alpha level of 0.10. If you notice, I just moved it in a little bit in the way it works. Let's think about it conceptually though. Conceptually, it's like this. What if I told you lunch will cost between $5 to $15? Could you reject $8? Why or why not? Lunch will cost between $5 to $15. Could you reject $8? Why or why not? Lunch will cost between $5 to $15. Could you reject $8? Why or why not? Who's got it in the chat? This is the conceptual stuff. No, why can you not reject $8? Lunch will cost between it is in the interval. So anything in the interval cannot be rejected at 1 minus the confidence level of the interval for alpha. So when you think about it, the interval looks like this. The outside of the interval, exactly, Angela, great answer right there. 8 is contained in the interval, 5 to 15. And Adriana, great answer too. Jessica and everyone saying the answers. 8 is contained in the interval, 5 to 15. Thus, we cannot reject it. What if we said something like 18? 18 could be rejected. Now, I didn't give you an associated confidence level like I am 95% confident that lunch will cost between $5 to $15. Well, if I did say that, you could reject 18 at the 0.05 alpha level on a two-tailed test. I'm going to repeat that again. Lunch, I am 95% confident lunch will cost between $5 to $15. Well, we could reject 18 on a two-tailed test at the 0.05 alpha level. Why 0.05? Because it was a 95% confidence roll. Why two-tailed test? Well, because confidence intervals and two-tailed tests are kind of mechanically similar on how they work and the percentages associated with them. 90% confident, 0.10 alpha on a two-tailed alpha test, on a two-tailed test. Does that all make sense and maybe help clarify that question? It's in like question 4 towards the end of it. And we might do a little type 1, type 2, but ask those questions if you had it, especially if I missed it. I think, yeah, Natasha, you get it right, that if we did a 98% confidence level, that would be a 0.02 alpha level on a two-tailed test. So great answers in the chat. Keep it up. Who has another question about what we're doing on the project and maybe how to interpret some output? Like if you want to see more output, interpreting it, and jump is really, really great. What do we need to include in the intro and the conclusion? Great question. The intro and the conclusion, especially for the intro, let's keep scrolling down. Wow, it's so easy to use this. Like when it's just like, I just got like free notepad right here. It's so great. Let's use blue. Blue's like nicer. Red's so harsh. 1, results. Results, results, results. Well, no, you should, let me do this. The intro, this is gonna sound crazy, but the intro should have an intro. So when you do your introduction, you should like orient the reader. You should say to them, you know, this was data collected for such and such company, so name the company, you know, trying to analyze, you know, what they're trying to analyze. I'm trying not to like literally write the intro for you right now, but you know, this was data collected for such and such company to analyze such and such process to see if such and such is happening. So, you know, a strong sentence right there, or maybe 2 sentences, can orient the reader to what we're trying to do right here. And thank you for everyone in the chat for helping each other out. 2, results. You need numbers. You need numbers. So like you put numbers. There needs to be numbers here. There needs to be actual numbers, actual data. You need to spell results correctly. So you need actual results. You need actual data. Another sip of Red Bull. So you need actual results, actual numbers to back your conclusions, because that's where we're going to go with all this. We're going to orient the reader, then we're going to give them our results, and then we're going to make a decision. So the final thing is what you choose to do, what the choice is. So we'll put here choice. Like, what do you choose to do? Your choice, your decision, your choice. Choose what to do. Tell me what we should do. Give me direction. You have been tasked with this. You've been tasked at looking at the new machines and the current machines, and then we want to know what we should do. You're being paid for your analysis to tell the company, what do we do? Now for the outro, so that's kind of a good idea for what to do in the intro. Make it strong, make it personal for the project, like here's what I'm suggesting, here's what I saw, here's why I'm doing this, these are the results, this is what the company should do. So you are being kind of direct, you are the one behind the analysis. Now for the outro, don't just restate results, because then you'll have given your results in the executive summary, and then you'll have given the full details of the results. But in the outro, you might look into maybe further conclusions, further possibilities. This is what happens when I don't have autocorrect. Further possibilities. Possibilities, sure, that works. Further possibilities, and also to importance of statistics. So it does kind of mention that. I think when you look at the grading key, it says, or at least what you have, it wants you to kind of talk about the importance of statistics. Try not to write things that are so Don't write in statistics. Don't write statistics are good. They help you decide things. Statistics is a good class and you should take it. The biggest thing what we're trying to do right here, and maybe I'm trying to give away this one a little bit by saying things like this, is when you think about how things were in baseball, statistics has changed how baseball does scouting. Statistics has changed how we get marketing done now. And statistics is about actually making data-driven decisions. Now, even in the past in baseball, they would take data on like who's doing well, who's pitching faster, who's a good recruit. But maybe it was more just kind of watching them. But nowadays, we have this holistic view where we can use all the numbers. We can take into account, well, is there really a difference, or is this difference likely by random chance? And if you've been doing the stats, when you hear by random chance, you should think p-value above 0.05, which tells you the results you're seeing are likely due to random chance. P-value below 0.05, unlikely due to random chance. So to me, and I might be giving a little bit of the outro away right here, so you're getting a little bit of a bonus, I do write the grading keys for these. The importance of statistics is knowing that you have the numbers to back your decision, that the decision you're making isn't so much like a gut feeling, it's more of a data-driven decision where you can say, well, here's the difference we observed, this difference was unlikely by random chance, so I believe, not just feel, but believe that this is the proper direction for us to go. I'm always like, see if we can find the data to back whatever we're doing. It's I think it's very important to do that. Does that help with the intro and the outro and all that good stuff right there? And I think there were some more questions. How do I interpret 3D and 3E? Adriana, I know, let's do those right here. 3D and 3E, which ones are 3D and 3E? Those should be, if I am correct, are those confidence intervals or tests? What do 3D and 3E say? It'd be good if I pull up I could pull up the project right here. That probably would be a good idea. Let me pull up the project. You guys might be saying it in the chat right here. Projects. So I am downloading the project as we speak so I can see it. And I didn't send an announcement to my class yet, but we've extended the date for the extra credit. You'll see it right here, and I'll announce it today in class, and I'll probably send an announcement too, but extra credit for the project can be obtained through the weekend. So if you're watching this now and it's the weekend, be like, oh, if I finish the project before the weekend is over, I can still get my extra credit. So big opportunity there. We wanted to give everyone a full weekend to have a chance to do it. Oh no, let's do 3D and 3E and stay in the p-value. You're welcome. Hey, we like giving you guys these opportunities. We want you to take advantage of them. We want you to have the chance to, yeah. Good. See, look at this. It is just a good day all around. 3D and 3E, perform a statistical test on the current machines. Okay, so this is a one sample t-test. 3D and 3E are the same thing, just on two different machines. All the happiness in the chat right now, I love it. So let's hop back over here and do a similar type problem. So once again, I am not doing your project. I'm doing problems very similar to it, and I'm interpreting results. This is a one sample t-test. This is a one sample t-test is what I'm about to do here. Now you might be confused because you might say, well, wait a minute. Brian, you have two samples. I'm going to analyze the high school GPA of students, and I'm going to do it by gender. Now this is not a two sample t-test, which we'll be seeing later today, because I'm doing it on both distributions. I don't want to mention two sample t-tests here too much. And if you notice, I've got stacked histograms. I'll show you this right here. If you hold Control or Command, you can go over here and put count axes on both of them. If that didn't work for you, just make sure you go to the second graphic and go to count axes. But if you hold Control or Command, it does it on both. You just have to hold Control and do something. So watch this. We're going to hold Control. So we're going to hold Control on the keyboard. So, oh, can't show you it. Oh no, what did I do? I broke everything. Never lift up the keyboard. Hold Control, and when we hold Control on the keyboard, we're going to go over here. We're going to click the arrow, and we're going to go to test mean. We're going to type in, let's test a mean of, let's see what we're going to test. Let's test 3.9. Now I'm choosing 3.9 for a reason. I want you to look at the output where I'm going to test. That's the hypothesized value. That sounds like you might be catching on. That's the hypothesized value. That's the value we're going to test. So maybe, I'm not saying no, but maybe that's what you would do. So good answer right there in the chat. This is a value I'm going to hypothesize. Now I just want you to think for a moment. If I test, if I test 3.9 with the first one, do you think I will reject? Look at that top distribution over there, all the way over there on the far side. Let's bring it over here. Can I? It's a back window now, so I might not be able to. Do you think on this distribution right here next to me that I can reject 3.9? I just want you to look at how close 3.88 is to 3.9. Do you think I will reject 3.9 right here? Look at how close it is. Now let's look at this one right here. This one is 3.6, and the standard error is 0.036. Don't look at the standard deviation. The standard error right there is actually s over square root of n. So this right here is s over square root of n. That's the standard error of the mean, s over square root of n. So you could literally do this. I could test it myself. I'm going to just show you how to do it manually. But I could do 3.9 minus 3.6. Did I do minus? Good. 0.5. I'm reversing it. 2 seconds. Observation. So that is the sample mean. That is y bar minus mu naught, which I just made up for my problem. This is a fake problem. Divided by the standard error of the mean, 0.36169 or so. And the t-score is -8. Now watch as we replicate this, but inside of jump. So I just did it by hand to show that it can be done on the test. We're going to hold control so it does it on both. We're going to go to test mean, and we're going to type in 3.9. Enter, enter. Oops, no. I guess you just have to enter once on this one. And then we're going to go here, and we're going to go to test mean, and we're going to type in 3.9 and hit enter one time. And you remember that t-score of -8 that I just found by hand? That t-score of -8, let's see how exactly close I was, -8.0186. Identical. It's behind me now, but there it is. So once again, I was able to find this by hand doing the formula y bar minus mu naught over s over square root of n. S over square root of n is the standard error, which we do get in jump right here. Jump, I'm going to put the standard error right above here. That is the standard error, which is s over square root of n. These are things that could be on the test, which is also why I want to highlight how to read this output. So do we use the same hypothesized mean for both? Yes, because we're testing 3,500 for both of them. So that is the, should we include screenshots of the test of the mean? Yes, definitely. That is your analysis and definitely include it. Yes to both. Adriana, great job. And great questions, Brianna and Angela. Keep those questions and answers coming, helping each other out. I want this to be a big help session for everyone on how to do the project. Once again, I'm not analyzing your results because these are totally different results right here. Condition 1 for these. What is condition 1 for these? What is condition 1? What is that condition 1? I'm about to flood the screen here with answers. I'll answer Angela's question. Natasha's right, it is random. For 3C, do we need to give a null and hypothesis? Yes. That's a good question. It's basically the same for both. You could technically, I'm writing the grading key as we speak. You don't need to do that. Here's my null and alternative for these. My null and alternative for these would be the null states that the true mean is equal to 3.9. And I want to see if the mean is different. I'm not doing the same thing as you. I'm not doing the same thing. I want to see if the mean is different. So I'm going to test to see if it's not equal to 3.9. And we'll go back to these results here in a moment. But remember, we're testing the true mean, and I'm testing the true mean GPA of students is equal to 3.9 as my null. And it'll be the same for both because I'm doing this for males and for females, I believe, is what I did. Which t-value would you use? And so there's going to be some p-values with some t-statistics right here. And yes, and Jackie, so the randomization condition is met because I randomly selected these. 10% because 10% is less than all the students, less than 10% of all students. And then the nearly normal condition is met because the distributions are only lightly skewed, I think. Thus, the distribution of the mean will be very, very normal. These are, I guess this one has a little bit more of a skew. You can see the mean is pulled down. So everyone see that's the mean right there. I'm going to make it a little bit bigger for us to see for a moment. But that is the mean. That little diamond's the mean. You could actually look at the value. You could look at the median. The mean follows the skew. It's probably due to the outlier also. So there's a little bit of a skew to this, but the distributions of the means will be nearly normal because the sample size is so large. That goes back to the central limit theorem. And the question in the chat was, what p-value, or I'm assuming that was the question, what p-value would I be using? Now remember, I'm doing the does not equals test, so let's bring this down a little bit further. Since I'm doing the does not equals test, which maybe you're not doing, double check which one you're doing, would I use the first, the second, or the third p-value? Would I use the first, the second, or the third p-value since I'm doing the does not equals test? Correct. Since I'm trying to make this as clear as possible. Since I am doing the does not equals test, I would use the first one. That is the does not equals test. This is the greater than test. Look, it has probability greater than t. And then the last one is the less than test. What is 36? Let me make this even bigger. What is 36 times 2? What is 36 times 2? So look at this right here. Whoop, there we go. What is 36 times 2? 72. Now it's 36.5. What is 100 minus 37? You should notice this relationship that the less than, the greater than equal up to 100. And then this one right here is double the smallest. Always kind of look for those things because we do put test questions where we're like, oh, here's one p-value. What other p-values would you be able to find? What if they are both statistically significant? So let's take a look. Now I have down here on the bottom, I have my, there we go. I have my does not equals test, I have my greater than test, and I have my less than test. Do you see this little, that little red line that goes right off the screen? The red line being over there. It's way, I'm pointing down at it, like I'm pointing to it. I just can't reach it or I'll go off the screen. I disappear, literally. That red line is your result. If you look, the mean was 3.6. That's where that red line is at. That red line is at 3.6. Where is this distribution centered at? This distribution for both of them is centered at 3.9 because the null goes at the center of the distribution. Now we would have evidence for the less than, and we do have evidence for the not equals to. Now either one will be quoted as 0.001 or less than 0.001, but you do have evidence for either of those conclusions. But for my test, I would use this first one right here and say, the prob less than absolute value of t, and this is just for my example, maybe not yours, hint, hint, hint. I'm using the does not equals, so I will use this one right here. If you were using the greater than one, you would use the second one, and if you were using the less than, you would use the third. That would pertain to the p-value of the not equal to, greater than, or less than? Yes. Does that all make sense on what I'm talking about here with which p-value to use? The choice right over here, the choice of which p-value depends on the alternative hypothesis you picked. The first one is the does not equals. So the first one is does not equals, the second one is greater than, and the third one is less than. So maybe you need to make sure to pick the correct p-value. And you can kind of tell because there's a greater than, less than, and then the does not equals has greater than absolute value of p. You got a p that is significant for both? I guess you could. Yeah, feel free to send me it. I'm guessing is the second one way more significant? The first one is probably significant with like 0.03 or 0.02 or 0.014. What is the first p-value you found for significance? And then I see a question from Brianna. For the 10% condition, in order to see if it is met, do we, yes, out of the 10,000. So theoretically, and a few people have asked about this, great question, Brianna, your sample of 200 out of the 600 is as though you took a random sample of 200 out of the 10,000 possible from that year. So everyone has a unique project. We gave you more data as though like, here's the things that could happen, but we don't want everyone to think that 600 is the population. The population is 10,000, and the prompt says that at the start. So really great question. So your p-value for the first was 0.68, but that would not be significant. Double check, and maybe send it to me via email too. The p-values should be generally one of them. So which p-value did you take? Oh, no worries. Good check. Hey, there's a bunch of time to wait to turn the project. Both insignificant. The second one should really be significant. We'll double check that. We'll take a look at it. The second one should definitely. Now, which of these are you using? Are you using the first, the second, or the third? The first, second, or third p-value? Are you using the first, the second, or third? But the third. Remember, if you're using the third, that means right here in the middle you put. Is this the way you wrote? Did you write that mu is less than? Did you write that? If so, that is the correct one. But if you wrote, and I hate that it scrolls back up, hypothetically speaking, if you wrote that mu is greater than, then you would go to this one. Does that make sense? Hypothetically speaking, if you wrote greater than that, you would do this right here. That's all right. No worries. You know, hypothetically. I hate that it does that. I got to remember you can't undo like that because I'm just trying to undo the last thing I wrote, and when I hit undo, it undoes that. Hypothetically speaking, if you wrote this, the p-value would be associated with this one right here. It'd be the first p-value. And what am I talking about? Specifically, I am talking about the p-values in the output right here. This is the first right here, this is the second, and this is the third. Up here, this is the first, which is the does not equals, this is the greater than, this is the less than. And you might be wondering, here I'm gonna show you one more thing with this. Watch this. Oh, I'm on the wrong screen. We'll go to test mean, we'll go to p-value animation, and cool. Here is the less than p-value, here is the greater than p-value, and here is the two-sided. Do you see how less than and two-sided, you just double the p-value? It's just taking it and reflecting it on the other side. And the less than and greater than are just complements of each other because you're just shading above or below the line. To do the two-sided alternative, you take the line and you reflect it on the other side. So you're literally just doubling the p-value. So I hope this helps out. And if you look at, what is that long line right there? That very long line is what? The center of the curve is the null value. That really long line right here is what? That is our what mean. I know it says estimated mean, but that is also known as our what? Who's got it? I wish I could throw out some points right now. Who's got what that very long line is? That is our sample mean. The null is the 3.9, which is the center of the distribution, but the sample mean was 3.88. And look at how close 3.888, not quite the alternative. It is sample mean, it is y bar. So this estimated mean right here is the sample mean. Let's take a look at the other one, and you'll see it looks quite different. In this one right here with the p-value animation, we're gonna have to stretch it back out here again. You can see that we landed, and where's our sample? Oh, I did a power animation. Let's not do power animation. P-value animation, here we go. In this one, we landed so far off the screen it's hard to see. There we go. So if you look, this estimated mean is our sample mean. No, this is the time to practice. Most people don't know this, and these are the advanced things that when you realize that that line is the sample mean. Now I want you to look at how far away that line is from 3.9. Is that line super far away from 3.9? Like just look at that line right there and be like, is that line close to 3.9? I don't know. Oh, it's super far away. And when you think about like your z-scores, it is 8. T-scores are basically the same thing. It is 8 standard errors away, which is basically 8 z-scores, and it's below the mean, so i.e. it's negative. So this is super far away, and the p-value is ridiculously small. Now you can do the greater than. Well, obviously there's no way that this is greater than because it wouldn't occur like that. This would not be something unlikely. And so down here, we do have evidence it's less than, and we do have evidence it's not equal to. If you notice that p-value, it's 2.9, and then when I do the two-sided, it's 5.8. Now that's not 5.8, that is technically 0.000000000000058, 12 zeros after the decimal, because it's in scientific notation up there. It's a very small number, as in this is super unlikely by random chance. We have very good reason to believe, very good evidence, that the true mean is below 3.9. Or not equal to, whichever one I choose to test right there. You could do the less than or the not equal to. Is there another question, and does this help out? This is all practice for the test. We've got tons of time right now, and understand what these things are showing you, and p-values is excellent right here. Ask those questions if you got them. Which other ones? We can do consoles. Definitely written like I have it. Definitely written like I have it. No, not exactly, but written like I have it right here. You can find mu, so write them out in scientific notation. You could also write it out if you want afterwards to say the null tells us that the true mean GPA of UT students is equal to 3.9. The alternative says that the true mean GPA of UT students is not equal to 3.9. Just that might be good practice for the test to make sure you can read the null and write it in scientific notation. So make sure to write it in scientific notation and be able to read it out. You won't be counted off on the project if you just write it in scientific notation, but on the test it really helps to be able to read them, but you should also be able to write them in scientific notation for the test. So if you reject the null, does that mean you fail to reject the alt? So remember, everything we say, we have two choices right here. Let's write them out, and I see another question too. On the null, we will either reject or we will, let's do it in green, fail to reject. That means on the alternative, when we reject the null, we will have evidence, or we will not enough evidence. So these are the only decisions we can make here. When we reject the null, we have evidence for the alternative. So I can say, I reject the null, and I think it was for men, I reject the null that the true mean GPA of males is equal to 3.9. I have evidence that the true mean GPA for men is not equal to 3.9. And once again, this is just the way the data turned out. I'll show it here again so you can wonder, how did Brian know that? This is the male distribution down here that we're looking at, and this is the p-value I'm looking at. When the p-value is low, we reject the null. As in, I tested 3.9, and thus I am rejecting that hypothesized value. So I have evidence that the true mean GPA for UT students is not equal to 3.9. Or, excuse me, true mean GPA for male students, there we go. And then when we scroll up here to females, we have different results. I what? And let's put it right there. Fail to reject the null hypothesis because I'm looking at this p-value right here for my results. I fail to reject the null that the true mean GPA of UT students for females is equal to 3.9. I did not find evidence for the alternative that the true mean GPA for UT females is not equal to 3.9. Did everyone see how we're interpreting that right there, and we're basically reading this off? You'll either say, I reject the null, I have evidence for the alternative, I fail to reject the null, I do not have evidence for the alternative. So if you reject the null, it's because you have evidence for alternative. And let's just do one quick example with that. One of my favorite examples to do, and since this is a public video, I want us to pretend we have a null here. A null is a 6-minute mile. There we go, that's a 6. And then the alternative would be not a 6-minute mile. Imagine you see me running around the track. If you saw me running around the track and you timed me and you saw me running around the track in 6:05, would you reject the null that I can run a 6-minute mile? So you see me running around the track and I'm running around the track at 6-minute mile pace, like 6:05, not quite 6. But would you reject the null that Brian can run a 6-minute mile, or would you not reject the null? What would you do? If you saw me run it around 6:05, if you think about it, if I can truly run a 6-minute mile, what should be at the center of the distribution? 6 minutes. So if you saw me run something that was close to it, even though it's a little bit above, that result would be likely if I'm a 6-minute mile runner. If I run it in 6:05, you'd be like, it seems likely given Brian's a 6-minute mile runner. But what if, probably more accurately, you saw me run a mile? Let's put this right here. Good, it's not too close. And then you go this way a little bit. If you saw me run my mile, and this is my result, remember the graphics we just saw, if you saw me run the mile in something closer to like 8 minutes, well, if I run a mile in 8 minutes, that's not too likely given I'm a 6-minute mile runner. So if I run a mile in 6 minutes, that would seem unlikely and you'd have evidence, and look the way I'm shading. Right here, I didn't do the not, so we could technically turn these into nots. If we're doing not, we have to go over here and plot this side too. So if we do not, we have to reflect it. So let's keep it not. There we go. Now we have our p-values shaded properly. So the mile time you saw me run when I run an 8-minute mile is unlikely given I am a 6-minute mile runner. So if you saw me run an 8-minute mile, what would you say? I reject the null that Brian is a 6-minute mile runner. I have evidence he's not a 6-minute mile runner. But if you saw me run a mile in 6:05, you would say, I don't reject the null. I fail to reject the null. I did not have evidence that Brian is not a 6-minute mile runner. There was not evidence for the alternative that he is not a 6-minute mile runner. Does that help understand? I hope examples like this where it's a little more contextual, where like you watch your friend running a mile and they're like, I can run a mile in 6 minutes. So you sneak out and you're like, they ran that mile in 8 minutes and they were really trying. That's evidence that they're not a 6-minute mile runner. So I reject that they are a 6-minute mile runner. I have evidence that they are not a 6-minute mile runner. And then over here, on the other side, you see them run it in about 6:05 and you're like, well, that's kind of what I would expect if they're a 6-minute mile runner. So I don't reject the null. I fail to reject it. I continue to believe that they're a 6-minute mile runner. I do not have evidence that they are not a 6-minute mile runner. I do not have evidence for the alternative with the over on the left. And the p-value is the probability of the result that we observe on that blue line, or a result more extreme occurring by random chance variation, given that the null is true. I see some other questions in the chat right here. So reject the null, does it mean, I hope that answers Natasha right there. I hope that helps with these examples. I like to do a lot of real world examples. So you told me to click on the arrow and to move down little graphic first question. I forgot to save it. I don't remember, Andrew. You told me to click on that arrow down. Thank you, Andrew. I love it, Andrew. Thank you. I found it. Never mind. Good. I'm just sitting over here slaying Null's letter. You're like, I got it, Brian. I'm good. So, last bit of Red Bull. Running out of that Red Bull. Other questions? Let's do at least one more. We could do proportion stuff right here. How many people do we have watching? So we had like 11 or 12 at the start. Concurrent viewers, we got 17. Good, yeah, thank you guys. What other questions are there right now? What other questions are there? Can all 17? You probably got it. You got this. You got this. I think you're doing great. I see a lot of our students here. You got to earn the A. You got to earn it. You can do it. You got the A. I have faith in you all. I have faith in every one of you. What other questions are there? We'll be hopping off here in just a little bit. We have time for like one more. Do you guys, oh, you'll do fine. Remember, if you get it done early enough, you can ask me to look at specific things. You can be like, hey, Brian, check out this part. Make sure I interpreted this correct. Don't be like, look over, I mean, you can tell me to look over your whole project, but I'll look over graphics. And obviously I can't grade the whole project, or I'd have to grade everyone's project, but I'll generally give a quick skim of a project to see if there's anything major I see, and I'll try to send back like 1 or 2 suggestions. So, you know, use those opportunities as best you can, like send it to me as early as you can. Be like, hey, I'm wondering about this part right here. Am I on track? I try to do that for as many as I can, and I just want you guys to have good direction on how to do the projects. So feel free to check that out. Let's do proportion stuff because we haven't done that yet. And let's check that out. Okay, so we are going to go here to analyze distribution, and we are going to look at, let's look at the proportion of people born in Tennessee by gender once again. And here we are. We're going to go to stack. We're going to hold down that control button, our quick trick right here, a little trick inside a jump. We're going to go to confidence intervals. We're going to go to 95%. Boom, we got our 95% confidence intervals. Done. Now, these do pass the success-failure conditions. Yours might have an issue on one of them. I'm just saying, maybe mention if there's an issue. If you have an issue, then in truth, we could have sampled more to fix that. You know, if we sample more, we won't have the issue where we don't have enough successes and failures. And how do I know that I have enough successes and failures? Well, because, let's take a look. We have right here in this data 71 people who are female who were born in Tennessee and 54 who were not. We have in this data right here 50 and 79. Both of those numbers are greater than or equal to 10. This is n right here, and this is p hat. Either can be p or q hat. So if these numbers are not greater than or equal to 10, you would fail the success-failure condition. So that's how we can check the success-failure condition right there on the project. Now, once again, the conditions are condition 1, random, condition 2, less than 10%, and condition 3, success failure. Why is it success failure? Well, because it's categorical. That is the condition for categorical data. If it was quantitative, it would be nearly normal. So we have the three conditions. Random, which means our data was randomly selected, which I took a random sample, thus it is. Less than 10%, well, these students right here, the 125 females is less than 10% of all UT females, and the 129 males is less than 10% of all UT males. And then the last condition being success failures, where I can see there's 54 and 71 successes and failures respectively for females, and 50 and 79 successes and failures respectively for males. Both are greater than or equal to 10. So make sure to mention that if you don't have enough successes and failures. With that said, do interpret your interval. It's a little bit of an issue, but do interpret your intervals. Maybe make a mention that, make a mention that there might be an issue because I do not pass the success failure condition. Not everyone may pass it for all of these. Don't worry, it's not a problem for like your project. It's just something that maybe you should notice and we want you to see while doing the project. So does that make sense right there? We're still going to interpret our interval though. So how do I interpret these intervals? Well, I'm looking at if someone is born in Tennessee. So make sure you know how to interpret your intervals. I want to see people type in the chat. I know my students know it. I want you to type in the chat the I am blank % confident that the true blank is contained in the interval blank to blank. So when we do this right here, if I'm talking about the true proportion of females born in Tennessee, I'm just going to fill it in that way. I am 95% confident the true proportion of females born in Tennessee is contained in the interval 48.04% to 65.15%. Make sure to know your skeleton interpretation for it. I am blank % confident that the true blank is contained in the interval blank to blank. And all we're trying to do is estimate what amount, nice job Adriana right there. And remember, the true blank will change because in this instance, the true proportion of females born in Tennessee is what we're estimating. That is the hardest thing to figure out for a lot of people, is part number 2. It's like, well, wait, the true what? And make sure you're doing the right one, because over here, I can change it and say something like, I am 95% confident the true high school GPA, because I think it's high school GPA technically, of females at UT is contained in the interval 39.57 to 39, no. I am 95% confident that the true mean high school GPA of females at UT is contained in the interval 3.817 to 3.957. Be very careful. This is one of the harder questions I think for people is interpreting your interval, but know what you just need to put in it. You need to give your confidence level. That's the first part you can see there in the chat. You need to give what you're talking about, and that's where we see the mistakes, because this is the true mean high school GPA of UT female students. That's a lot right there. That's a lot to say. So the second blank is usually the hardest, and then the third blank is just giving that interval right there that you can see as I slowly go off the screen and disappear. That's how to interpret intervals. That's how to do it. And type 1, type 2 error, let's just do a little bit on that, and we'll cover a lot of the project, a lot of help in this video right now for those who need it. So when we do type 1, type 2 error, here's the thing. A type 1 is when, do you see, wait, watch this. You see I got 1 right here? A type 1 is when the null is what? When the null is what? A type 1 is when the null is true. Now if the null is true, what would be a mistake? Type 1, Jessica, nice job right there. Type 1 is when the null is true. And what do we do? What's a mistake if the null is true? What would be a really bad idea to do to the null if it's true? If our null is true, it'd be a really bad mistake. I know it was a student who actually made this up, to reject it. You're right. A type 1 is the null is true, and we reject it, and get ready for your 2 F's in the type 2. In a type 2, the null is false, and we fail to reject it. Notice how the type 2 has the null is false and we fail to reject it. It's 2 things in the type 2. So in a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. It's got the 2 F's in it right there. Nice job, Jessica, in the chat. Keep it up because it's very easy to just flip-flop. It's very easy to flip-flop which is which. Type 1 is not the right color. No, we scrolled up again. We've got 7 minutes. We got this. We're loading up. Type 1 is associated with your alpha level. Type 2 is associated with beta. So I guess that's beta. We'll do a B like that. A B for Brian, a B for beta. So type 2 is associated with beta. If you increase alpha, and let's do this, there are 3 things that can control beta. This is kind of giving away a little bit of help on this. The 3 things that control beta are alpha, and sample size, that's n right there, and effect size. The three things, effect size is the difference between the null and the truth, and the sample size is how many you sample, and the alpha level is your rejection point at the percent of time you reject due to random chance, like alpha 0.05 is the 0.05 rejection criteria we often use for statistical significance. So if you increase alpha, you decrease beta. If you increase sample size, you decrease beta. If you increase effect size, which you really can't do, you can't control the difference between the null and the truth. If it were to be bigger though, theoretically, you would decrease beta. Now, all of these are inversely, or all of these are positively related to power. So if you increase any of these, power goes up. So if you increase your alpha, power goes up. If you increase your sample size, power goes up. If you increase your effect size, power goes up. But you don't really increase your effect size because you can't control it. You can't control what the difference is between the null and the truth, because the truth is the truth and you can't control what the truth is, so it just is. But also I put the down on beta because if you increase alpha, beta goes down. If you increase n, beta goes down. Reason being is because power is 1 minus beta. So since power is the inverse of beta, anything that brings beta down brings power up. Does that make sense theoretically right there? Like beta going down, think about what's the lowest beta could be. Beta would be 0 and then power would be 1. And power is the ability to correctly reject the false null. That's a good definition. We sometimes put that on the test. It's basically, if you're like, what does it mean to correctly reject the false null? It means the ability to find results when results exist. It means we should be able to reject the null and not make a type 2 error. Type 2 error is when we fail to reject a false null. So what should we do to the false null? We should reject it. And if we make a type 2 error, we failed to reject the false null. So there were results that were statistically significant that we did not find. We could increase our sample size, we could increase our alpha, but maybe alpha's fixed because people don't want to mess with the 0.05 criteria, and that's a good thing. Or you could have a larger effect size, but a lot of times you don't control effect size. Does that help out with all of these questions? I'm going to hop off here in just a moment, but I want to open it up to you in the chat if there are questions. And thank you all for being here. This is recorded, so you can check it out later at any time. That's the last of the Red Bull. Any other last questions? Let's see if there are any. Did this help out a good bit? Do people feel a lot better? I will be in office hours on Thursday. I think we're also going to do some stuff on Friday. We're probably going to do some YouTube videos, maybe helping out. I'm going to reopen some of the assignments. We'll talk about that in class. And because there were some of my Pearson issues, and I want to make sure everybody is working on the assignments. And so I think on Friday we'll try to do a special stream where we'll do some we'll do some assignment work. It'll probably be another public stream. So if you were watching this, check out Friday. We're going to do some homework help, some quiz help, and kind of work through some of the problems and show how to do them, just to make sure we're ready for test 3. Awesome. Any other last questions? We'll give it time for one more question, and then we're going to start preparing for interview. You're welcome, Lindsay. So good to see everyone here. So thank you, everyone, for being here. I hope this helped. I hope you better understand how to interpret things in the project, how to make the jump output, and please work on the project early, get those bonus points, and ask those questions if you got it. I am going to put up the exit screen, and it's almost 5:05, so let's bring in Crash just to have some fun.
Yeah.